What we're going to do is talk about equilibrium. And it's a concept that's a little bit challenging for students. It takes a little bit of time to get used to, but we're going to try our best here. What equilibrium is when a reaction reaches a point where the amount of reactants turning to products is equal to the amount of products turning to reactants. And so that's the definition, and I'm going to talk about that definition as we go through. But we've kind of talked about how there are some reactions that are reversible. And so a reversible reaction is one in which it can go backwards. And let me give you an example. Here is an example of a reversible reaction. We have hydrogen gas plus bromine gas making hydrobromic acid. It's a balanced chemical equation, but there's something that we need to change about it to tell us that it's a reversible reaction. And what that is the yield sign. If it is a solid arrow, kind of like that, if it's a solid one direction arrow, that is telling us that it's not reversible. To show that a reaction is reversible, what we do is we write a half arrow in the forward direction and a half arrow in the reverse direction. And so what this tells us is that this reaction is a reversible reaction. And so when the hydrogen gas and the bromine gas become hydrobromic acid, the hydrobromic acid can actually go backwards to become hydrogen gas and bromine gas. And so that is a reversible reaction. Now again, equilibrium is where the amount going forward is equal to the amount going backwards. And so I'm going to go ahead and give you an example here that will maybe help illustrate what that looks like. And so this is going to help us understand, this little example here is going to help us understand what equilibrium is. So imagine I have $100 and imagine you have $0. And what's going to happen is every single day I'm going to give you $1. So every day I'm going to give you $1. And every single day you are going to give me 10% of whatever you have. So every day I give you $1, and every day you give me 10% of what you have. And so on day one, if you take a look, I have $100, I'm going to give you $100. I mean, not $100, I'm going to give you $1. So every day I'm giving you $1. Now, every single day you give me 10%. Well, you have $0, so what is 10% of 0? It's $0. You're going to give me $0 on day one. So after the end of day one, I will have $99, and you are going to have $1. All right. Now on day two, I'm going to give you $1. So again, $1 is going to go this way, and you're going to give me 10%, which what is 10% of $1? It's $0.1, which is 10 cents. So if I give you $1 and you give me 10 cents, what will end up happening is I will have $98.10 and you will have $1.90. All right. So again, day three, I'm going to give you $1. You're going to give me 10%, and let's go ahead and see what that looks like, which it'll look something like that. Now what I'm going to do is I'm going to do like 2 or 3 days all at the same time. And so this is again on day 4. I'm going to give you $1 every day. I give you $1. You give me 10% of what you have, which we'll just round to the nearest penny, I guess. And so this is day 5, what it's going to look like. I will end up with $96.56, and you will end up with $3.44. So again, every day I give you $1, every day you give me 10%. Now, what I want to ask you is, what is it going to look like in the end? If we did this an infinite number of times, what will the final result be? How much money will you have? How much money will I have? I want you to pause the video and I want you to really think about this. In the end, how much money will I have and how much money will you have if we were to continue this an infinite number of days? So go ahead and pause. Okay, so what I'm going to do is, let's just say we somehow get to the point where I have $90. I don't know how many days that's going to be. It doesn't matter. Again, we're going to, we're imagine we're doing this an infinite number of days. But I get to $90, and you get, if I had $90, that means you would have $10, right? Because I started with 100, you started with 0. If I have 90 now, that means you have 10. And again, it doesn't matter how many days it took. What matters is that we somehow got to this point. If we got to this point here, what would it look like on this day? Well, I would give you $1. $1 would be going towards you. Now, how about you, though? How much would you be giving me? Well, you would be giving me 10%. What is 10% of 10? It's $1. And so at the end of this day, I'm giving you $1, you're giving me $1, I end up with 90, you end up with 10. Now, what about on this day? Well, I'm going to give you $1, you're going to give me $1, and what would end up happening is I would end up with $90, you would end up with $10. And I hope you see that once we get to this point, we can do this forever, and I will always have $90, and you will always have $10. This is the point in which equilibrium has been achieved. Notice how the amount going forward is equal to the amount going backwards. We do not have the same amount. You have 10, I have 90. However, the amount that I'm giving you is equal to the amount you're giving me, and that is what equilibrium is. Now, think about this in terms of a chemical reaction. In a chemical reaction, when equilibrium occurs, the amount of reactants becoming products is equal to the amount of products becoming reactants. Notice how we can still have more reactants and less products, but it can also be the other way around, where we can have more products and less reactants. And so let's go ahead and take a look at these practice problems here. Now, something that, let's go ahead and answer number 2. Equilibrium is reached in a chemical reaction, and let's go ahead and read A. It's when the rates of the forward and reverse reaction become equal, the concentrations of the reactants and products become equal, the forward reaction stops, all reverse reaction stops. And so in this situation, it's not D or C, because if you think about our example here, again, if we keep going, if we do this every single day, it's not stopping. I'm giving you $1, you're giving me $1. Also, it cannot be B. The concentrations of reactants and products aren't necessarily equal. There is a situation in which they are equal. It's very rare, but it's not when equilibrium is achieved. Because if you take a look, do you have the same amount of money as I do? No. The answer is A. The rate of the forward reaction is equal to the rate of the reverse. The amount going forward is equal to the amount going backwards. Before we enter the next problem, let's go ahead and talk about what a K-value is. When equilibrium is achieved, we can calculate the K-value for the reaction, which tells us how much product or reactants there are. If a reaction has more products, think about what this K-value would be. Would the K-value be greater than 1, less than 1, or equal to 1? So again, if we have more products, for example, let's say we had 10 products and 1 reactant, and I'm just making these numbers up. I can make it 10 and 2 or whatever. Well, what would end up happening is if we have more products, the K-value would be greater than 1 because 10 over 1 is greater than 1. If you have more of a numerator than you have in the denominator, it's going to be greater than 1. But what about if we had more reactant? If we had more reactant, let's say we had 5 reactants and 2 products, and that's again the concentration. It's not that there's 5 different compounds in the reactants. It's just, let's just say we had a concentration of 5 and the products is a concentration of 2. Well, if you take a look, if there's more reactants, if you have more in the denominator, that's going to make a K value of less than 1. Now, what if the products equal the amount of reactants? Well, if the products equal the reactants, that means K will be equal to 1. Because, for example, let's say we had 5 reactants and we had 5 products, that would give us 5 over 5, which is 1. Now let's talk about K value in our example here. Again, every day I gave you $1, you gave me 10%, and that would go on forever until the point that we get to $90 for me and $10 for you, and then every single day we would give each other $1. And so for this particular example, what would the K value for this example be? Well, the K value, again, is the products, which you would end up with $10 in the end once we reach equilibrium, divided by the reactants. So in this situation, we would have a K value that's less than 1. For this particular unit and for pre-AP chemistry, you will only have to worry about identifying if a K value is greater than 1, less than 1, or equal to 1. And again, if it's greater than 1, it's going to be more products. If it's less than 1, it's going to be more reactants. So let's go ahead and take a look here. For number 3, each of the following represents a weak acid placed in water. We will talk about later what a weak acid is. Rank them in order of increasing K value. So what I'm going to do is I'm going to show you how to go about answering this first question here. So for this first example here, you can see that we're starting with 16 acid molecules. Now, when these go into solution, some of them will dissociate into solution, and then when they do that, they go back to together as the acid. Now, if you take a look, we started with 16, and then when it goes into the solution, I counted that 13 of them stayed intact once equilibrium was achieved. So that means 13 of them are still intact. Go ahead and pause the video real quick and think about that for a moment. 16, we started with 16 here. In solution, we end with 13. If we ended up with 13, how many of them became product? Well, we started with 16. Now we have 13. That means 3 of them must have gone over to the product side. Now, if 3 of them went to the product side, that means we're going to have 3 of these and 3 of those. Because for every one of these will produce 1 of those and 1 of those. So in this situation, we end up with 3 products and 13 reactants. Now, in reality, just like in this example, even though you have $10 and I have $90, we have dollars that are going forward and backwards. And so the amount of money is not changing, but we do have some of my money going to you and some of your money going to me. And so this still is going forward and backwards. We still have it going forward and backwards, but it's just that we will always have 3 in the product side and 13 in the reactant side. Now go ahead, pause the video, and I want you to do this same exact sort of setup for problem 2 and 3. And then we'll talk about ranking them smallest to largest. So after counting everything, you'll see that we start off with 16 here, we start off with 15 here. We end up with 2 and 2, because we ended up with 13. That means 2 of them went over since we started with 13. So if we remember that K is products over reactants, if you take a look here, this is going to be 3 times 3. This is going to be 1 times 1, 2 times 2, divided by the reactant. So this is 3 times 3 over 13. So I'm going to go ahead and write that here. 3 times 3 over 13. This one is 1 times 1 over 15. And then this one is 2 times 2 over 15. If you take a look, the one with the smallest K value is clearly this one. This one is the smallest. The one with the largest K value is going to be this one. And so this is the smallest, so this is the first, this is the second, and this is the third. For this particular problem, it's asking us to determine at which point is equilibrium occurring, and if the K value is greater than, less than, or equal to 1. Now what this is showing, these are 6 different pictures through time. This is time 0, this is time 1, this is time 2, 3, 4, and 5. And so these are different pictures through time. If you take a look here, we have H2 plus I2 yielding HI. And you can see here that we only have H2 and I2 within this. So we have iodine gas and hydrogen gas. There's only reactants in this first picture here. Now when we go to time 1, notice how we now have these here. And in this particular picture, there's 6 of them. Now if you go to the next picture, we now have 10 of them. Notice how we went from 0 product to 6 of the product to 10 of the product. Now, what's going to happen once we reach equilibrium? Well, what's going to happen is the amount of product will not change. And so go ahead and pause the video, count how many of each product, how much of the product is in each picture, and determine when equilibrium has occurred. All right, so I've counted them for you right there. If you take a look, when we go from time 4 to time 5, which is picture 5 and picture 6, you can see that the number of products is not changing. We have 14 in one, 14 in the other. This is the point right here in which equilibrium was achieved. Now there are still products turning into reactants, and there's still reactants turning into products. It's just the amounts are unchanging in that moment. Now the other question is the K value greater than, less than, or equal to 1? And the question you need to ask yourself is there more products or are there more reactants? Well, there's clearly more products. And so because there's more products, that means that the K value of this chemical reaction is going to be greater than 1.